Okay, for objective number 4, we're calculating potential energy. Again, this is gravitational potential energy. Number 1 says a person weighing 70 newtons climbs a 4-meter ladder. How much potential energy does that person have on top of the ladder? Let's show your work. So start with potential energy. We know the formula for potential energy is mass times gravity times height. In this case, their mass is 70. Gravity, since we are assuming that it's on Earth, we haven't been told otherwise, is 9.8, and the height is 4 meters. When doing the math, we multiply these together. We end up with 2,744 joules. For number 2, Phil lifted a load of bricks that weighed 112 newtons onto a platform 9 meters above the ground. Pete lifted the load of bricks that weighed 97 newtons onto a platform 8 meters above the ground. Whose bricks have more potential energy? So we're going to compare both Phil and Pete. Phil, we want to find the potential energy that his bricks produce, and Pete, we want to find the potential energy of his bricks. Now, in the case for Phil, there's 112. That's the mass. Of course, we're on Earth, so it's 9.8. His gravitational pull, and he lifted it up 9 meters. When we do that math, we end up with 9,878 joules for the bricks that Phil lifted. For Pete, we have 97. That's the mass of his bricks. Again, we're here on Earth, 9.8 meters per second squared, and he lifted them 8 meters into the air. When we do that math, we end up with 7,605 joules. So we see that Phil had more. Now for number 3, it says, referring to the roller coaster diagram from objective 2, at which point does the roller coaster have the most potential energy? Well, that same roller coaster diagram is one that we've seen before. It looks something kind of like this. The most potential energy is the point at which it's going to be the highest above the ground. So that would be position A. Now, why is it position A? Why do we think it has most potential energy? Well, as we said, it is the highest point, the highest position above the ground. Number 4, refer to the roller coaster diagram in objective 2. At which point does the roller coaster have the least potential energy? Well, the least potential energy would be the point at which it's closest to the ground, and it's not going to be B, but rather it's going to be F, over here to the far right. Why is that? Because it is the lowest position above the ground. Now let's go ahead and take a look at objective number 5. Objective 5 has to do with the law of conservation of energy. It says a book on the desk has 5,693 joules of potential energy on its mass and the distance above the floor. When you drop the book, the actual value of kinetic energy is 5,600 joules. You assume the extra 93 joules is destroyed in the moving of the book. What is the fault of your thinking? Be sure to include the definition. Okay, our fault of thinking, and then as actually part of the definition, is that since energy cannot be created or destroyed, it can only be changed from one form to another. The 93 joules cannot be destroyed or cannot be lost, either way you want to describe that. It is changed from potential energy to, could be heat in the form of friction, Could also